Good morning, students. Welcome back to the online class. It's your maths class. Last 2 weeks you learned the basics, but today onwards we are going to learn the lessons properly. So please take your maths note and be attentive. I hope students you all got the maths ebook through WhatsApp. If you missed that in WhatsApp, I gave the link in the description box. Just take it and download your ebook. Then, if you have doubts, you can go through that. Also, learn it from that. Okay, let's start the lesson. Unit 1, Relation and Functions. Relation and functions. You can understand this clearly when you clear in the basic, that is set. So when you're in 9th grade, you learn the lesson 1, set language. Can you remember? So using set only we are going to define the relation and function. So tell me, what is set? I think already you learned that in the basic class. What is set? Set is a collection of well-defined object. So there should be some rule in the set. So collection of well-defined object. How can you define a set? How can you denote a set? So using capital letter like A, B, C, etc. up to Z. You can use any letter for set. So if that is capital letter, that is set. Okay. So for example, I am writing a set A equal to set of all vowels A, E, I, O, U. So remember it, the object should be small letter. So the set should be capital letter. So whenever you saw that capital letter, you should remember that's a set. Okay, don't confuse, that's a set. So the small letter or element of the set. Also, any other examples of set? That is odd numbers, set of all odd numbers. I defined as B equal to 1, 3, 5, etc. Okay. So using this only, using set we are going to define relations. Okay, relations and functions. 1.2 ordered pair. So what is the meaning of pair? Pair means 2. Am I right? So 1, 2. Okay, it is a pair. Then A, B. I written 2 things. That is pair. Then X, Y. These are pair. Am I right? So here that is they given that ordered pair. You should define the ordered pair as within the bracket. That means these two numbers are connected with proper relation. That is known as ordered pair. You cannot connect it simply. There should be proper relation. So if you say these two are ordered pair, there should be some relation between these two numbers. Like the same, if you say these two are ordered pair, there should be some relation between these two numbers. Like the same here. So how can you make the ordered pair? That we are going to learn now. Next one is Cartesian product. I read out this definition. You have to learn it because they may ask this question for 2 mark. Okay. So it's a 2 mark question. Cartesian product. If A and B are two non-empty set. Already I told you, if there is capital and small capital letters, that denoted as set. They given that A and B are two non-empty set. So non-empty meaning is there should some elements in A and B. There should not be null set. There should be elements in A and B. So if A and B are two non-empty sets, then the set of all ordered pair, they given the ordered pair as A, B. You know that how can you denote the ordered pair? That is A, B such that A belongs to A and B belongs to B is called the Cartesian product of A and B. That's all. The meaning is, if you write the ordered pair A and B, the rule is this small a should be the set A. That is A belongs to A. The small b belongs to the set B. That is small b belongs to B. So this is called the Cartesian product. So also it is denoted by A cross B. You should read this as cross. It is in multiplication symbol. Don't use into. Some of you may read it A into B. That's not correct. The correct form is A cross B. Just write here. A cross B. Okay, you have to read this as A cross B. Then this Cartesian product is also known as cross product. Okay, Cartesian product is also known as cross product. How they denote in symbol? A cross B. Whenever you see the A cross B, just you remember that A cross B means Cartesian product. That is equal to set of all A comma B, ordered pair, set of all A comma B such that this A belongs to the set A, then small b belongs to the set B. That's all. I hope you understand it. When you learn the example, you should be clear about this. Then I want to ask a question. It is A cross B. Now, what about this B cross A? What about this B cross A? So, both are not equal, okay? Both are not equal. Don't confuse, both are not equal. This B cross A should be, here, first the set is A, so first element from the set A. So, here, first set is B, so first element from the set B. Second set is A, so next element from A, such that this B belongs to capital B and small a belongs to capital A. So whenever you write this, both are not equal. Look at here, A comma B, here B comma A. For example, it should be like that, 1 comma 2, it is A cross B. Sometimes here 2 comma 1, that is B cross A. Okay, don't get confusion. These are not equal, both are different. So your Cartesian product definition is this, up to this. Have to learn it. A cross B is not equal to B cross A. Am I right? But the number of elements in A cross B is same as the number of elements in B cross A. So we will prove that in the coming example. So remember it. Both are different, both are not equal. But when you count the number in the set A cross B, also when you count the number in the set B cross A, the numbers are equal. Okay, this is note. Next note. Sometimes this A cross B may null set, empty set. If and only if there's only possibility this Cartesian product will be empty. Sometimes this A set A may empty set, otherwise B is a empty set. Okay. Suppose A is empty, this A cross B is empty. Otherwise B is empty set, this A cross B also a empty set. Here. Then F. Number of elements in the set A is P. Think about. Suppose the number of elements in the set A is P and number of elements in the set B is Q. Okay. Then our Cartesian product A cross B. Number of elements in the Cartesian product will be PQ. This is one of the important one more question. So if N of A is P, That means number of elements in A is P, also number of elements in B is Q, means when you take the cross product of A and B, that number of element is P and Q. When you multiply the both, you will get it. Okay. Okay. Let's go through the examples. You will understand this concept, every concept clearly.
Students, you have to learn the portions what I mark with yellow color in your text. Okay.
Example 1.1. If A equal to set of all 1, 3, 5 and B equal to set of all 2, 3, then first subdivision, find A cross B and B cross A. That means the Cartesian product of A and B, also the Cartesian product of B and A. You have 3 subdivision, we can do one by one. Okay. First, we can write the given. What they given? Given A equal to set of all 1, 3, 5. Also B equal to set of all 2 and 3. Okay. Next we can find out the Cartesian product A cross B. You know that we know what is the formula to find out the Cartesian product. How can you define the Cartesian product? A cross B equal to set of all ordered pair A comma B such that this A belongs to capital A, then B belongs to capital B. Okay. Then using this, we are going to write the A cross B. So A cross B equal to set of all. The meaning is we are going to connect every element of A to B. For your understanding, I'll just draw it. If it is A, if it is set B, the elements are 1, 3, 5. In B, the elements are 2 and 3. We are going to pair the elements, every elements of A to B. For example, I can connect 1 with 2. I can connect 1 with 3. That pair we are going to write here. 1, 2 and 1, 3. First we got pair. Next we can connect with the next number. 3, 2 and 3, 3. So 3, 2, 3, 3. Next we can connect with 5. So 5, 2 and 5, 3. Can you find any other possibility? No. So we conclude this set. So it is A cross B. This one I drawn for your understanding. It is no need. If you need, you can draw it. I use it for your understanding. So first part over. This part over. Next we can find out B cross A. Already you know both are not equal. Okay. So next we can find out B cross A. How the B cross A will be? Set of all. First element from B, second element from A. Such that B belongs to capital B, A belongs to capital A. So our element, every element is going to be like this. Okay. So here you drawn the figure as A and B. So here next thing, how it will be? First one will be B. Next one will be A set. Don't forget it. So B elements are 2 and 3. A elements are 1, 3, 5. So B cross A, we are going to write this set of all. Tell me now. Just try with me, okay? Pair 2, 1, 2, 3, 2, 5, then 3, 1, 3, 3, then 3, 5. Okay, that's all. So now we found out A cross B and B cross A. Okay. Next question. And second question they ask, is A cross B is equal to B cross A? If not, why? Already you know both are not equal. So we can write. Otherwise just you can check it. You know you have this A cross B. Look, A cross B is 1, 3, 1, 2, 1, 3, etc. Look at B cross A. Whether it is same as 1 cross 1, 2. Second question, second part. Is A cross B is equal to B cross A? Already we know both are not equal. If not, why? So we are going to prove that with first part. Look at the first part. You have A cross B. You can take this as equation number 1. Next, B cross A. This is equation number 2. So when you compare the both, look at 1, 2, 2, 1. Whether both are same? No, both are different. 1, 3, here 2, 3. Totally both are different. So we can write as from 1 and 2, A cross B is not equal to B cross A. We found that. Okay. Sorry, B cross A. If not, why? Why they ask? They ask why. So we can say that. First look at, say that 1, 2 is not equal to 2, 1. Am I right? Like the same. 1, 3 is not equal to 3, 1. Okay, these are all the reasons. You can write etc. Many reasons. Okay. Next, third part. Third part, show that number of elements in A cross B is equal to number of elements in B cross A, that is equal to number of elements in A and number of elements in B. Already in first part we found that A cross B and B cross A. So I can write that from equation number 1 I can find out the number of elements in A cross B. From equation number 2 I can find out the number from B cross A. Just check it and write A cross B. Listen. A cross B. How many elements are there? 1, 2, 3, 4, 5, 6 elements. Also, how many elements are in B cross A? 1, 2, 3, 4, 5, 6 elements. So, both have 6 elements. Clear now? So, if both have 6 elements, we can prove that both are equal. Also, we have to prove that n of A cross n of B also same. So, first we have to find out what is n of A. That means number of elements in A. How many elements in A? You can check it now. 1, 2, 3 elements in A, 2 elements in B. So, n of A is 3, n of B is 2. Okay, what we need now, n of A cross n of B. So, n of A cross n of B is equal to, what is n of A? 3 into, what is n of B? 2. Just multiply it, what do you get? 6. So, if you take equation number 3, 4 and 5, you can write using 3, 4 and 5, we conclude that n of A cross B is equal to n of B cross A is equal to n of A cross n of B, because all the right hand sides are equal, so definitely the left hand sides are equal. Okay. Next example, example 1.2. If A cross B is equal to, so it is Cartesian product, so this set will be ordered pair, set of all 2, 3, 3, 4, 5, 2, 5, 4. So it is Cartesian product they given. We have to find out the set A and B. Find A and B they ask. So using A and B we can find out A cross B. What is A cross B meaning is set of all A comma B such that A belongs to A, then B belongs to B. So all the first element, otherwise first coordinates from the set A, all the second elements, otherwise second coordinates from the set B. So from that Cartesian product we can pick up the first coordinates, otherwise first elements, that is known as set A, because all the A belongs to capital A. If you pick all the second elements, that is from set B. That's all. Very simple problem. So given A cross B is equal to set of all 3, 2, 3, 4, 5, 2, 5, 4. It is given. Okay. We know that we have A equal to, what is A? Set of all first coordinates of elements of A cross B. So it is A. So how can you write A? That is A equal to set of all first coordinate. What is first coordinate? 3. Next, look at, we return 3, again here is 3, no need to write that again. Then 5. Look, again here is 5, no need to write. So simply we found out that A equal to set of all 3 and 5. Then tell me now, what is B? B equal to set of all second coordinate of elements of A cross B. Okay. Now we can choose the second elements, that is B equal to set of all. So 2, 4, again here is 2, we already written 2, again here is 4, we already written 4, that's all. Okay, if you have doubt, just you can check it. Here the number of element is 2, here the number of element is 2. So when you multiply that, what we get? 2 into 2 is 4. How many elements in here? 1, 2, 3, 4. Just you can check it. One more time I told you how to check it. How many elements in A? 2 elements. How many elements in B? 2 elements. Just multiply it, you get 4. Then count the elements in A cross B. 1, 2, 3, 4 elements. So your answer is correct. You didn't miss any other number. Okay. Next, example 1.3. Let A equal to set of all x belongs to n such that 1 less than x less than 4. Then B equal to set of all x belongs to w such that 0 less than or equal to x less than 2. And C equal to set of all x belongs to n such that x less than 3. Then verify these through 2. Have to verify the both. So these two are also known as distributive property of Cartesian product. Okay, it is a note, just you have to know it. Just I am telling these two are also known as distributive property. We have to verify the both. We can do one by one. Before that, we have to explain, otherwise extend the terms. It is in the rule form. We have to separate the elements. So solution, given A equal to set of all x belongs to n such that 1 less than x less than 4. Know that n means set of all natural numbers. Natural numbers start from 1, 2, 3, etc. Okay. So our set will be A is equal to set of all x belongs to n such that this x will be, elements will be 1 less than x less than 4. Our element in between 1 and 4. But you should not include 1. If there is equal to, you can include 1. If there is equal to, you can include 4. But there is no equal to, just they given less than. Okay. So, the next number is 2, 3. Do you need to include 4? No need. Okay. That's all. We found out A. Next we can find what is B. B equal to set of all, given that x belongs to W such that 0 less than or equal to x less than 2. Okay. Now they given x belongs to W. W means all numbers. All numbers start from 0, 1, 2, 3, etc. Okay. Our element x in between 0 and 2. Also we can include 0 because we have the equal to symbol. That is equal to 0, 1. Shall we include 2? No. That's all. Okay. Then we can write C. C equal to set of all x belongs to n such that x less than 3. Okay, so again it is natural number. Natural number start from 1, 2, 3, etc. So our element is less than 3. So already it start from 1. Less than 3 means we should not include 3, 1 and 2. So set of all 1 and 2. So now we have the elements. What are the elements in A? What are the elements in B? We know that. What are the elements in C? Now we can start the part 1. We have to prove A cross B union C is equal to A cross B union A cross C. This we have to prove. First we can consider this. Consider this LHS. That means A cross B union C. Okay. From this, what is B union C? I am asking you, what is B union C? Union means you have to collect all the elements from B and all the elements from C. You should not miss anything. That is known as union. You should collect all the elements from B and C. So the elements in B are 0, 1. And the elements in C are 1 and 2. But already 1 is there. Look, already 1 is here. So just we can write 2. Clear now? We collected all the elements A union B. Next, we can include this cross. So now A cross B union C. So what is A? Just write the A. A is 2, 3. So set 2, 3 cross the set 0, 1, 2. So we are going to find out the cross product. That means cross product means all the elements will be pair. Okay, all the elements will be pair. So that is set of all 2, 0, then 2, 1, then 2, 2. So we connected every element from this one to the first element. Then we can connect the second element. 3, 0, 3, 1 and 3, 2. So we completed the LHS part. Take it equation number 1. Next we can do the RHS part. Then we can verify both are equal or not. So consider RHS, that is A cross B union A cross C. So we are going to verify it. First we can do step by step. First you can take A cross B. So A cross B. For that you have to know what is A and what is B. So A is 2 and 3. B is 0 and 1. So 2, 3 cross 0, 1. We are going to do the cross product. So just you can make it 2, 0. Set of all 2, 0. Then 2, 1. Next 3, 0. Next 3, 1. So A cross B over. Next we can find out A cross C. So A cross C equal to, already you know this is A, 2, 3. Then cross C is, what is C? C is 1, 2. So C is 1, 2. Just you can make the cross product, that is set of all. Ordered pair 2, 1, 2, 2. Then 3, 1, 3, 2. Okay, we did that. Next, what we have to find out? We have to find out the union of the both. So I can write A cross B union A cross C, that is equal to, we have to find out the union of this and this. So union meaning is we have to collect all the elements from this one and all the elements from this one. Okay, just you can write this one first. 2, 0, 2, 1, 3, 0, 3, 1. This set union, the next set is this one. 2, 1, 2, 2, 3, 1, 3, 2. So now we can write the union of these two. Union means we can collect. First we can write 2, 0, 2, 1, 3, 0, 3, 1. Next 2, 1, already that is here, 2, 1. 2, 2 is not here, so 2, 2. 3, 1 already here, so no need to write. Then 3, 2, no 3, 2. So 3, 2. So take this as equation number 2. Now we can compare equation number 1 and 2. Whether both are same or not, just we can compare it. Look, equation number 1, 2, 0 is here, 2, 1. So this element is here, this element is here. Then 2, 2. 2, 2 is here. 3, 0. Then 3, 1. 3, 2. So when we compare this 1 and 2, we can conclude that from 1 and 2, we can conclude that A cross B union C is equal to A cross B union A cross C. This we verified. Okay. Now we can go to the second part. Next part, same thing. First we can consider the LHS. Consider A cross B intersection C. Okay. So first we can write the B intersection C. So what is B intersection C? You have to write it. So what is the meaning of intersection? In intersection, you should collect the common from B and C. So intersection means common, don't forget. Union means all the elements. Intersection means common. So what is B? 0, 1. Then intersection. What is C? 1 and 2. What I said, intersection means we have to collect common. So what are the common things from the both? The set 1. It is singleton set. Only one element is here. So now we can cross with A. So A cross this B intersection C. So what is A? A is 2, 3. Then cross. Intersection C is 1. So we are going to do the cross product. So definitely our outcome will be ordered pair. So 2, 1. Next 3, 1. So that's all. Okay. It is equation number 3. You can take it as equation number 3. So next we can write. Next one, consider the RHS A cross B intersection A cross C. First you can take A cross B. A cross B is set of all. What is A? First you write the A. A is 2, 3. A is 2, 3. Then cross. Next B is 0, 1. We are going to do the cross product. So our outcome will be ordered pair. That is pair it 2, 0, 2, 1. Then 3, 0, 3, 1. Okay. So first part over. Next we can do the next one. So A cross C is equal to set of all. Write A. A is 2, 3. Then cross. Write C. C is 1, 2. Next you can do the cross product. So if it is cross product, our outcome will be ordered pair. So pair it 2, 1, 2, 2. Next pair it 3, 1, 3, 2. Okay. So these two over. Next we can do the intersection. So next step is A cross B intersection A cross C is equal to, you write the set first. The set of all 2, 0, 2, 1, 3, 0, 3, 1. First set over. Next intersection. Next set. A cross C, that is here. 2, 1, 2, 2, 3, 1, 3, 2. So we are going to do the intersection. Intersection meaning is we are going to pick only the common terms. That is equal to common terms. Look, 2, 0. Is here 2, 0? No. So don't take it. 2, 1. Is here 2, 1? Yes. So you can take it. Then 3, 0. Is here 3, 0? No. Don't take it. 3, 1. Is here 3, 1? Yes. So you can take it. So our result is 2, 1 and 3, 1. Take the question number 4. Now we can compare the 3 and 4. Compare the 3 and 4. Yeah, both are same. So we verified that from equation number 3 and 4, we conclude A cross B intersection C is equal to A cross B intersection A cross C. That's all. Students, you have 2 homework questions. Tomorrow I'll check it. That is exercise 1.1, first question and third question. Don't forget it, do today itself. If you miss it, when you reopen the school, definitely you will confuse about it. Don't forget it, learn the daily portion, also do the homeworks. Thank you.